Hi, this lesson is about the equation and the graph of a circle. So let's consider the circle here in this picture. This is a circle with a center at the point HK, where H is the x-coordinate and K is the y-coordinate. And there's a distance that we call a radius, that is the distance from the center to any point along the circle. And I'm going to call that point XY. So r is our radius. Okay, so since radius is a distance, I'm going to use the distance formula to come up with the equation of the circle indicated here in this picture. So remember, your distance formula uses 2 points. The x-coordinates of the corresponding points are subtracted, and then the y-coordinates are subtracted. Each of those differences are squared. You add the differences, and then you take the square root. So as a reminder, our distance formula, when we first learned it, looked like this: x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared, and we're taking the square root of the whole expression. All right, so we're applying that here to our circle. Instead of calling it D, we're going to call it R. R is the distance from the center to a point on the circle. So my 2 points are XY and HK. So that's exactly what you see inside of this here in pink. And if you square both sides of that equation, you get the equation below inside the box. So when you square r, you get r squared. And when you square a square root, you just get the expression on the inside. So that's what we call the standard form of a circle. R squared equals x minus h squared plus y minus k squared. Okay, and that's the equation of the circle with a center at hk and a radius of r. Okay, so let's use that information to identify center and radius and then sketch the graph. Okay, so here's our first example. We want to identify the center and the radius, then sketch the graph. And there's 2 examples. Let's look at A on the left side. So on the left side, I have an equation of x minus 1 squared plus y minus 3 squared equals 4. So the center is the opposite sign of whatever is associated with the x and the y inside of that binomial squared. So your center is 1, 3. And your radius is the square root of the number that's on the other side of the equal sign. The square root of 4 is 2. So our radius is 2. That means that there are 2 units from any point on the circle starting at 1, 3. So here's my graph. Now I know it doesn't exactly look like a circle. That's because I did it freehand, but it's supposed to be a circle. So the point 1, 3 is right here in the middle. And then you're going to draw 4 points to the right, to the left, up and down from that center point. I'm going to make my center point purple so it's easier to see. All right, so if you go 2 units to the right, you're here at 3, 3. And if you go 2 units to the left, well, you're here at negative 1, 3. Then you want to go 2 units up. So if you go 2 units up from the center, you end up here at 1, 5. And if you go 2 units down from the center, you are right here at 1, 1. Then you do your best to connect those 4 points on the outside into a circle. So that's the easiest way to sketch the graph of a circle, is to travel right, left, up, and down from the center the number of units indicated by the radius. Okay, so let's look at another example. Here I have part B. This is x plus 2 squared plus y plus 1 squared equals 9. Notice that the signs in the middle are both pluses, and in my first example, they were both minuses. So when you're selecting your center, you always want to pick the opposite sign of whatever's given in the equation. So here the center is negative 2, negative 1. So that's the first point that you plot. So that's the point that you see right here, negative 2, negative 1. Then you want to identify your center. Your center is the square root of 9, which is 3. So that means that you have to go 3 units to the right, to the left, up and down from the circle. So if you go 3 units to the right, well, that's the point 1, negative 1. If you go 3 units left in this direction, well, that's the point negative 5, negative 1. You basically are counting the number of points to the left of negative 2. So that's why from negative 2, you end up at negative 5 because you're going left, so you're subtracting 3 from negative 2. Then you also have to go up 3 units. So remember, this is the point negative 2, negative 1. So this time you're going in a vertical direction. So you go up 3 units from here, and that leaves us at negative 2, positive 2. And then you go down 3 units, and you get the point below at negative 2, negative 4. Then again, do your best to connect the 4 points on the outside to create your circle. All right, so this time you're going to be given the information, the center and the radius, in order to determine the equation. So all you really have to do is remember the format of the equation, which was up here in this pink box. Okay, so let's go back to those 2 examples. Here on the left, I want to find the equation of the circle with a center at negative 3, positive 4, and a radius of 1. So the first coordinate, that's the one associated with x. The second one is associated with y. And remember, you always want the opposite signs. So the first binomial will be x plus 3 squared. The second binomial will be y minus 4 squared. And on the right, you just need to square the radius. So that's why we have 1 squared on the right. So 1 squared is just 1. So your answer is what you see here, x plus 3 squared plus y minus 4 squared equals 1. Okay, let's do another example. Here on the right, I have a circle with a center at 2, 0 and a radius of 4. So my equation is x minus 2 squared. Here, doesn't really matter whether you put plus or minus because 0 is neither positive or negative. So the one associated with y, that's y minus 0 squared. But when you simplify that, we know that y minus 0 or y plus 0 is just y squared. And here you have to square 4. So your equation is x minus 2 squared plus y squared equals 16. Okay, so sometimes your equation is not in standard form. And when it's not in standard form, we need to complete the square. And so that's a skill that we learned in a previous section when we were solving quadratic equations. And we're going to complete the square on both the x expression and as well as the y expression. So here are the directions. We want to put the equation in standard form and identify the center and radius. And this is what our equation looks like. So that certainly doesn't look like the ones we've been working with so far. It's not the equation of the circle in standard form. I cannot pick out the center or the radius from this equation. All right, so what does it mean to complete the square? So the first thing you need to do is rewrite your equation so that your x's are together. You can ignore what you see here in orange for now. So I put my x terms next to each other. I also put my y terms next to each other. And the constant got moved to the other side. So instead of having plus 2, I subtracted it, and I get negative 2 on the other side. So now it's the completing the square part. And those are the numbers that you see in orange. Okay, so completing the square. If you remember, that means you take half of the coefficient of x, so 1/2 of negative 6 is negative 3. Then you take negative 3 and you square it, and that gives you a value of 9. That number gets added to the equation. But this is an equation, so whatever you do to one side, you have to do to the other. So if I add 9 to the left, you have to add 9 to the right side. Then I do the same thing with the coefficient of y. Coefficient of y is 4. Half of 4 is 2. And then when you square 2, that has a value of 4. So that means that you have to add 4 to both sides of the equation, here and here. All right, so what that does is that it creates two perfect square trinomials on the left side. So when you factor x squared minus 6x plus 3, well, that's just x minus 3 times x minus 3, which we know is x minus 3 squared. And when you factor y squared plus 4y plus 4, well, that's just y plus 2 times y plus 2, which is y plus 2 squared. And when you simplify the right side, negative 2 plus 9 plus 4, well, that has a value of 11. So that's my equation now in standard form. So if I'm asking for center and radius, the center, remember, is the opposite signs of what's associated with x and y. So that's 3, negative 2. And the radius is the square root of the number on the other side. So here, my radius is the square root of 11. All right, so we'll try that again, that skill. Let me just get rid of these lines. Okay, so here we can identify the center and radius and then sketch the graph of the equation x squared plus y squared plus 14y equals, plus 13 equals 0. All right, this one's actually less complex because notice that I don't have an x term. I only have an x squared term. So here, when I rearrange it, I have x squared plus y squared plus 14y, and again, move the 13 over to the other side so it becomes negative 13. Now I'm going to complete the square on the y term because there is no x term. So half of 14 is 7, and when you square 7, you get 49. That's the number you see in pink. You add 49 to both sides of the equation. So the x is fine, the x squared is fine, just copy that down, but you want to factor the perfect square trinomial of y squared plus 14y plus 49. That's y plus 7 times y plus 7, which is y plus 7 squared. And on the right side, negative 13 plus 49 is 36. So in terms of center and radius, this has a center at 0, negative 7. Remember, there is no x term here, so therefore the center associated with the x coordinate is just 0. And the y coordinate is the opposite sign of what you see here. So that's why we have negative 7. And the radius is the square root of 36. The square root of 36 is 6. So that means when you graph it, you want to plot 0, negative 7 first, and then go 6 units, right, left, up, and down. Sometimes I say north, south, east, and west. It's the same thing. So here's my center, 0, negative 7. And if you go 6 units to the right, you end up here at 6, negative 7. If you go 6 units left, you end up here at negative 6, negative 7. Then you have to do the same thing north and south. If you go 6 units north, you end up at negative 1, 0. And if you go 6 units south, you end up at 0, negative 13. And then again, connect all the points on the outside and you have your circle. All right, so this one requires us to do a little bit more work. We want to find the equation of a circle with a center at 3, 4 that passes through the point 5, 7. Remember, to find the equation of a circle, you need both a center and a radius. So I know the center, it's 3, 4, so that part is fine. But I don't know the radius. So I'm going to go back and use the distance formula that I mentioned before. Remember, the distance is the radius, the distance from a point on the circle, and that point is given, 5, 7, to the center, which is also given, gives you the radius of the circle. So here I plug into the formula. It's the difference in the two x coordinates. So I have 5 minus 3, and you square that, plus the difference in the y coordinates, that's right here, 7 minus 4, and you square that result. And when you do the subtraction, you get 2 squared plus 3 squared inside the radical. Square each of those numbers, and you get the square root of 4 plus 9. And we know that the square root of 4 plus 9 is just the square root of 13. You have to add what's inside the radical. 13 doesn't simplify, but it does allow us to come up with the equation of the circle. So the circle in the standard form would be x minus 3 squared plus y minus 4 squared equals the square root of 13 squared. But when you square the square root of 13, you get 13 on the right side. So the equation of the circle is in the box. Okay, so you're ready to try the homework for this section? Good luck.